Hey guys, happy Monday. We're going to keep trugging along. We're at lesson 35. We're going to talk more about integrals, okay? Really, they're called definite integrals, but like I said, I generally don't say the definite. The book is already kind of dropping it. So, we're going to talk about integrals. With that, we have to talk about derivatives, right? Because it's just going back from derivatives. So if you know, so we're going to review for just a minute. If you know y equals, let's say x to the fourth, then y prime would equal 4x cubed, correct? Yes. So we're going to talk today about going backwards. Meaning, if we have this answer, we know f of x equals 4x cubed, what is the big F? Okay, meaning what function's derivative is 4x cubed. Okay, the first thing we're going to talk about is a constant. Okay, if you have, I'm going to go back a little bit, kind of going back and forth. If you have y equals 5x, what is the derivative of 5x? Y prime is simply 5. Okay? Or we could say even dy. What's the differential? Okay? The differential would be 5 dx. That's right. Don't forget that dx. Okay? So now going backwards, if we are just given a constant, if we are given dy equals, I'm just going to do a different problem, 8 dx. What is y? Okay. So here we're starting at the bottom, and I want to go backwards. Okay. So if we just have a constant, we can pull that constant out, and we know the derivative of 8x is really 8. Now, also with integrals, there's something else we have to have out there, because we know that could be a full line. Okay, it could be 8x plus 7, 8x minus 12, 8x plus 52. Okay, there's a constant out there. We're going to check y. If I took the derivative of y, would I get 8 or 8 dx? The derivative of 8x is x. The derivative of any constant is 0. We get back to the beginning. Okay? So there's a rule about a constant k. Okay? Meaning, if you have an integral of 8 dx, I'm just going to kind of keep the same problem. Okay? And I ask you to find the integral of 8 dx. We can actually pull that constant out and say, what's the integral of dx? Okay? What's the integral of dx? It's simply x. So we would have 8 times x plus c. Okay, so it would be 8x plus c. Sometimes this is going to help us when we have other things going on. Okay, when we need to pull a constant out. Okay, it might not always be obvious. Okay, so if you have something like, we want to find what's the derivative of 4x squared. Okay, if we have 4x squared and I ask you to find dy dx, what are you going to tell me? Okay, there was a rule, we don't talk about it that much because it's so simple, that we could pull this 4 out and find the derivative of x squared. Okay, what's the derivative of x squared? It's simply 2x raised to the first. If our constant is out, we know that it's simply 8x. Okay, we've always just done 2 times 4 and then subtract the 1. That's exactly what we're doing, okay? Just slowing down, kind of going so we can see a little easier if we're going backwards, okay? to the point of, what if I give you 8x as an answer? Okay, so what is the integral? I'm not even going to put 8x. I'm going to put 4 times 2x dx. Okay, sorry, this was another thought bubble. Another problem. If I have 4 times 2x dx, I'm going to scroll just a little. Okay, and I want to pull the 4 out. 4 times the integral of 2x dx. Whose derivative is 2x that you know? And we could look back up here. Whose derivative is 2x? And you would say x squared. Okay? So this is really 4 times x squared plus that constant c. They do have a wonderful little statement in here. I forgot where it was. I read it earlier. Recognizing when to move out a constant will come with experience. Because if we were just given this 8x, we might not have known what to move out. Okay? So we're going to have some things that are going to make it a little simpler. But there's another box that says, be careful. Do not ever move a variable across the integral sign. Okay? You can move constants all you want. Don't ever move a variable. Okay? So here's the problem. Integral. What's the integral of 4 cosine t dt? Okay, the dt is because we've done the differential. Now I'm going back and saying, what is my function? Here's our constant 4. We're going to move it out. 4 times the integral of cosine t dt. Okay, what is the integral of cosine t? Yeah, you all said it. It's sine t. So that 4 times sine t would be 4 sine t plus some constant c. Okay, see how that's going to work? It's not going to be a huge big deal, really, but sometimes it might be. Okay, what if I want to know what's the integral of sine u du? Okay, whose derivative is sine u? Well, I'm thinking it has to be cosine, right? Wait, the derivative of cosine is negative sine, right? Is that the problem that we have? No. Okay, so right here's where we're going to use the constant rule, okay? So if I have the integral, and I really need this to be negative sine u du. Did I change anything when I multiplied negative 1 times a negative 1? No, I didn't. Okay, because that's still a positive 1. It's still a positive sine u du. I didn't change anything from beginning, from the first step to the second step. But now, can I pull out one of these and leave one negative sine u on the right side? Yes, I can. So I'm going to pull out a negative 1. I'm going to have the integral of negative sine u du. Now, do we know whose derivative is negative sine u? Of course we do. It is cosine. Cosine u, the derivative of cosine u is negative sine u. Okay? Now we're going to use our constant and bring it down to just be a negative cosine u, and not forgetting our constant out at the end. Okay? So we can use this little constant thing to our advantage when we need to. Okay? We can check, we can go on, yes. All right, so they go back to that 4, they do the cubed 4. Here we go. What is the integral of 4x cubed dx? Okay, this has been a short, easy answer. We understand if we take the derivative of x to the 4th, we would get 4x cubed, and then we would put our plus c out there. We've seen that several times. Or 5x to the 4th. That's just going to be x to the 5th plus c. We've seen that several times. But let's really look at what we are doing, okay? Because now we're going to have a pattern. Because when you take the derivative of something, so if I wanted to take the derivative, y equals x to the 4th, I'm going to go really slow and say, how do we find y prime? Whatever that x raised to the x, what we did an n, times x to the n minus 1, if this was x to the n. Yes? Of course we did. So now, if we want to go backwards, can we take what we were beginning with, and instead of subtracting 1, could we add 1 to get from 3 to 4? Yes, we can. And instead of multiplying by n, can we simply divide by whatever that number is we're going to? Yes. So I'm going to take this 4x cubed and do a little trick with it. If I'm taking the integral of 4x cubed, can we simply say, pull our 4 out, and have an integral of x cubed, but then we're going to say take that exponent n plus 1, okay? Then we're going to have to divide by that n plus 1. Okay, so instead of subtracting, like we do when we're taking the derivative, we're going to add 1 to take the integral. Okay, so if I simplify this, it's going to be 4 times x to the 4th divided by 4. What happens to these 4's? They cancel. Are we left with x to the 4th plus our c? Yes, so x to the 4th plus c would be our final answer. Okay, so we've dealt with all the ones that have worked out nice and pretty, but now we're going to not. So here we go, here's the little box. Integral of x to the n dx. Okay, we can find that answer to be x to the n plus 1 over n plus 1 plus your constant c. Okay, this is going to be our new rule if you're given integrals, okay, to find what their derivative was. Okay, so let's try another problem. We're going to start with one that's in the book. What is the integral of 5s to the negative 20 ds? Okay, if you want to pull the 5 across, which is kind of where we started, it would be 5 times the integral of s to the negative 20 ds. Okay, now when we pull out that integral sign, that's when we're going to add the 1. Okay, so here we go. We're going to have 5 times s to the negative 20 plus 1 divided by negative 20 plus 1. Okay, we need to simplify this, right? So this is 5s, what's negative 20 plus 1? Negative 19. Negative 20 plus 1 on the bottom is negative 19 also, plus c. In general, they're not always going to look very pretty, okay? Most all the time, this exponent and this number here will be the same unless they can reduce with the constant that we pulled out. Okay, like that last one, the 4 and the 4 times x to the 4th divided by 4. Those 4's can cancel. Sometimes these numbers will be able to cancel. Okay, let's do another one. What's the integral of, we're just going to say 8, x to the 15th power, dx, sorry. Okay, what's 8? The integral of 8x to the 15th dx. So we're going to pull the 8 out. 8 times the integral of x to the 15th dx. Do our, I would say shortcut, but if I go from integral to derivative, we're going to take x to the 15 plus 1 divided by 15 plus 1. It's 8 times this plus my c. And sometimes I add the c at the very end. And sometimes I forget it, and that's not good either. Okay? Now, what is this going to equal? We're going to have 8x to the 16th divided by 16. Can we reduce this 8 and 16 to 1 and a 2? So our final answer would be x to the 16th over 2 plus c. Sometimes they'll reduce. Now, it actually kind of is probably a good idea to do that check. Okay, so if I'm given y equals x to the 16th over 2 plus any constant c, you can put a number there if you want, what is the derivative? Okay, well, this is really 1/2 x. So that's not a derivative yet. I'm going to take that off. X to the 16th. Right? So I'm taking my 16 down. 16 times 1/2 comes x to the 16 minus 1. 16 times 1/2 is 8x to the 15th. Is that what we started with a dx on it? So this would really be dy equals this dx. Okay? So anytime you're doing integrals, anytime, you can always check by just taking the derivative of what you found. Okay? It's always an okay idea. We're going to do one more because they start getting a little harder. Okay? I gave you one that was fairly easy. They're asking, what is the integral of 1/3 times the cubed root of t squared dt? Okay? Should I rewrite this? Yes, you should. Okay? If you ever ask yourself that question, the answer should be yes. So I'm pulling out the constant of 1/3. I'm going to put the integral sign, and now I'm going to rewrite. This is t raised to the 2/3 dt. Okay? Here we go. We're going to add our 1. So I'm going to have the 1/3 on the outside. T raised to the 2/3 plus 1 divided by 2/3 plus 1. Okay? I have to add some fractions. It's going to happen. So t, 2/3 plus 1, that should be 5/3. So I'm going to have a t to the 5/3. And I'm going to have a 1/3 divided by 5/3. Should I go ahead and do that? Yes. 1/3 divided by 5/3, I'm going to flip and multiply by 3/5. My 3's cancel, and I'm left with 1/5. Right? Yeah, 1/5, which I can simply just put as 1/5. Okay, does that make sense? This is my 1/5 times t to the 5/3 plus c. I'm going to not take that away. But this is where we get to. Could we check it? Do I really need that 1 on the top? Not necessarily. But this is my constant 1/5. If you want to check, take t to the 5/3 divided by 5 plus c. If that's what y equals, how are we finding the derivative? Okay? So it would have 1/5 on the outside times 5/3. T to the 5/3 minus 1 minus 3/3, that's 2/3, right? This 5's cancel, I'm left with 1/3, t to the 2/3. Does that look familiar to you? Yep, that's exactly what we were writing. Okay? All right, we're going to stop there. We don't have any homework for tonight. We'll finish this lesson tomorrow, and I'll talk to you later. Bye.